Hello students, welcome to lecture number 3. In the last lecture, we discussed about generation of computers, history of computers and the types of computers. In this video, we will be talking about block diagram of a computer system. So in the last two lectures, if you have any doubt in any topic, then kindly mention your doubt in the comment and I will provide the clarification or solution for your doubt. And if you are new to this channel, then kindly subscribe to this channel. And if you find this video useful, then kindly like this video. So without any further delay, let's jump into the video. So talking about the agenda, in this lecture, we will be talking about only a single topic, which is the block diagram of a computer system. So here you can see the block diagram of a computer system. Here is the input unit, then we have the output unit, and this is the storage unit, which consists of secondary storage and primary storage, and then we have the central processing unit, which consists of control unit, arithmetic logic unit, and one more thing, the CPU also consists registers, which are used to temporarily store the instructions and data which are processed by the arithmetic logic unit. In this diagram, there are two types of flow. The solid lines indicates flow of instructions and data, and the dashed line indicates the control exercised by the control unit. Means through the solid line in this diagram, the flow of data and instruction is indicated, and using the dashed line, how the control instructions or how the control are provided by the control unit to the various components of a computer system are indicated by the dashed line. So now we will be discussing every component or every component of a computer system in detail. So the computer system hardware comprises or consists of three main components. First one is input output unit, second one is central processing unit, and third one is the memory or storage unit. The input output unit consists of input unit and output unit. The central processing unit means CPU performs calculations and processing on the input data to generate the output, and the memory or storage unit is used to store the data, instructions and output information. Now we will be talking about every component in the detail. So first one is the input unit. The input unit of a computer system performs the following functions. It accepts or reads instructions and data from the outside world, means user. So whatever input or data and instructions the user is providing, that are provided or that are read by the input unit. Then it converts these instructions and data in a computer acceptable or understandable form, because the data which is provided by the user is normally in the human understandable form, like in the English language, like that, but the computer does not understand the language we use. So the input unit convert these instructions and data in a form which computer can understand, and then it supplies the converted instructions and data to the computer system for further processing. So after converting the data and instructions in a form which is understandable by computer, it supplies these converted instructions and data to the computer system so that the computer system can process that instructions and data. So the input is generally provided to the computer system through the input devices like mouse, keyboard, microphone, scanner, trackball, etc. There are many other input devices also, but these are some common input devices through which a user provide input to the computer system. Then second one is output unit. The output unit of a computer system performs the following functions. It accepts the results produced by the computer which are in the coded form and hence cannot be easily understood by us. So when the computer system performs any calculations, then it generates the output which is in a form which computer understand but which we do not understand. So it accepts the result produced by the computer which are in the coded form and therefore cannot be easily understood by human beings. Okay. Then it converts this coded result to a form which is acceptable or which is readable or which is understandable by the human being. Okay. Then it supplies this converted result to the outside world, means to the human or to the user. Okay. The output is provided by the computer using the output devices like printer, monitor, speaker, etc. There are many more output devices, but these are some common output devices through which the computer system provides the output. Then comes the storage unit or the memory unit. The storage unit of a computer system holds or stores the following: data and instructions required for processing, means the data and instructions which are received from the input devices, it holds those data and instructions for processing. Then intermediate result of processing: whenever a computer performs any calculation, then some intermediate results are generated, so the storage unit or the memory unit holds that intermediate results of the processing. Final result of processing before they are released to an output device. The storage unit also stores the final result of a operation or of a calculation before that final result is provided to the output device. The computer system has two types of storage or memory. First one is primary and second one is secondary. Okay. So now talking about the primary storage or memory. The primary storage or primary memory holds the running program instructions. So it is very important to understand that whatever program or whatever instructions the computer is processing, all those program or instructions should be in the primary memory before they can be processed by the computer. It holds data, intermediate results and results of ongoing processing of jobs. So when the computer is performing some kind of calculations or processing the jobs, then whatever data is required for that calculation, what are the intermediate results generated and what is the final result, all these information, all these things are stored or held by the primary memory. The primary memory is faster in operation than the secondary memory. It has small storage capacity than secondary storage. The storage capacity of primary storage is smaller than the storage capacity of the secondary storage. It is more expensive than secondary storage. It is more costly than the secondary storage. It is volatile in nature, means if the power off or if the system is shut down or if the computer is turned off, then any data which is in the secondary, which is in the primary storage will be erased or will be lost. CPU can directly access the information stored in the main memory. So CPU can directly communicate with the main memory, but CPU cannot directly communicate with the secondary storage or with the secondary memory. Then comes secondary storage or memory. It holds the stored program instructions. It holds the stored program instructions. So whatever instructions you want the computers to execute, if you want to store these instructions permanently in a computer system, then we use the secondary storage for permanently storing the programs in a computer memory. It holds the data and information of the stored jobs. So whatever data is needed, what is other relevant information for those programs, those all data is stored permanently in the secondary storage. It is slower than the primary storage. Its processing speed or its read and write speed is slow than the primary storage. It has larger storage capacity than primary storage. The primary storage has very less storage capacity, but the secondary storage has a very large storage capacity, generally in the GBs or TBs. It is lot cheaper than primary storage. Primary storage is more costly relatively to the secondary storage. It is non-volatile in nature, means even if the computer is turned off, the data stored in the secondary storage will be not erased, means it will be there in the secondary storage. CPU cannot directly access the information stored in the secondary memory. The CPU cannot access the secondary storage directly by any means. Magnetic disk, optical disk, magnetic tapes are some examples of the secondary memory. Then comes the central processing unit, means CPU. So CPU is the brain of a computer system. It controls, coordinates and supervises the operation of a computer. So the CPU is the main component which controls, coordinates and supervises the operation of a computer. It is responsible for processing of input data. Whatever data is provided to the computer system, the CPU is the one which is responsible for processing all that input data provided by the user. CPU consists of arithmetic logic unit, means ALU, control unit, means CU, and CPU register. So in the diagram you can see arithmetic logic unit plus control unit plus registers equal to central processing unit. So CPU consists of ALU, CU and registers. Arithmetic logic unit, means ALU, perform all the arithmetic and logic operations on input data. So all processing on the input data is the responsibility of arithmetic logic unit. Okay. ALU is the place where the actual execution of instructions take place during processing of operations. So ALU executes all the instructions of an operation. Control unit, means CU, manages and coordinates the operation of all other components of a computer system. Okay, so control unit controls all other components of a computer system. The control unit checks the sequence of execution of instructions and controls and coordinates the overall functioning of the units of a computer system. So control unit is responsible to check that what will be the sequence of execution of the instructions, and how the other units of a computer will work, how the data will be transferred from one unit to another unit, in which sequence the data will be transferred, and then on which device the output will be uh, sent. All this is the responsibility of the control unit. Additionally, CPU has a set of registers. Okay, CPU has a set of registers. So registers are the fastest unit of memory. Okay, these are the fastest unit of the memory which work at the same speed at which the CPU works. So registers and the CPU both work at the same speed. So registers which are contained in the CPU, they are used for temporary storage of data, instructions and addresses and intermediate results of the calculation. So the data and instructions which needs to be executed comes into the primary memory, and then the CPU is executing the instructions at a given time. That instructions and its data is moved into the registers which are in the CPU, and when the CPU performs some calculation, then its intermediate results and what will be the address of the next instruction and what data is needed for the current instructions, all these things are stored in the CPU registers. Okay, so this was about the block diagram a computer system. I hope that you have understood this properly. Still, if you have any doubt, then kindly mention in the comment. And in the next lecture, we will be talking about primary and secondary storage in detail, and the various access methods also we will be discussing in the next lecture. So if you find this video useful, kindly like this video and subscribe to this channel. We'll see you in the next lecture. Till then, bye bye.